Today I had the pleasure to talk to Professor Dr. Nikos Salingaros and Professor Dr. Michael Mehaffy. They are both lecturers for architecture in the United States, although not at the same university. And they both researched and worked on works related to Christopher Alexander, who is famous to be the author of the book The Pattern Language. And they wrote academic research papers related to him, both together and also separately. And today we're going to talk about how to improve the results of contemporary AI technologies such as Midjourney or DALL-E by feeding the AI with knowledge and data related to Christopher Alexander. For example, the book The Pattern Language, or more importantly, the 15 properties coming out of Alexander's book, The Nature of Order. So please enjoy the talk. And as you know, always feel free to let me know in the comments what you think, because YouTube loves comments. So the more you comment, the more this video will be spread via YouTube. That's what we want, to improve the contemporary worldwide architecture situation. So let me know where you agree with what we talk and also where you disagree with what we speak. So enjoy. Hello, Nikos. Hello, Michael. Nice to talk to you here about our current podcast. So in this version, I will let you two guys let's speak the most, right? Because you have something to speak about, and I will just comment here or there, right? That's our plan for today.
Hi, Sebastian. Thank you. Yeah, so this is going to be more of a conversation, but we're going to show some slides and talk about the issues here for AI. We're all talking about AI and thinking about it and using it, but we need to figure out what the deeper issues are, how we use it in architecture, what the broader issues are for technology and for culture. Nikos, you want to say something briefly?
Well, I think this is going to be an informal conversation about extremely important topics that are not well known. So it's going to be very interesting for a wide variety of people in the audience.
Yeah. So just a plug of our organization, Systasis Foundation. We say tools for transition. We're looking at how the world is changing and how we need to be prepared for that, how we need to be thinking about the challenges ahead and how we can meet them. And I want to just briefly note that artificial intelligence is, of course, a structure that mimics natural intelligence, the natural neuron pattern of our brains, right, which are very deep networks, deeply interconnected networks of neurons that represent reality and that evolve and learn and transform as they check all of the information in their deep data sets, and we form a picture of the world, and we're able to do things like talk and interact and plan and create. And that is exactly what AI does in a way of recapitulating that kind of network structure, right? We start out with a target or goal of some kind, and a prompt, and then that goes into a deep network, and there's whether it's a large language model or a set of images that are gradually transforming and becoming more and more and more like what the data set suggests it should be, whether it's an image of a building or a cat or anything else in the world, or a piece of text that's telling you something about the world, just like we do. So that's an important model of what AI is that we want to hold in our minds. And I think we need to contrast also what you might call a deep net structure, a really, really deep, highly evolved network, like the network of, say, all the encyclopedia knowledge that's represented in Wikipedia. That's a very, very deeply interlinked data set. And in fact, many AI programs use Wikipedia for that reason, and other large language models like that. Contrast that with what you might call shallow nets, which are just very sort of fragmentary, little bitty pieces of network that are sort of created on the spur of the moment. They don't have a deep evolutionary history. They don't have a deep network behind them. They're what we call shallow nets. And that is what the world is full of today, clogged up with today in many ways. You know, the way fake news and social media and all the things that are really cluttering our world with superficiality and with junk knowledge, junk stimulation, junk ideas. And this is very dangerous because it erodes our cultural richness, our ability to solve problems and navigate our way in the world as a species, our ability to be intelligent. It's artificial stupidity, if you will, right? And so there is.
Michael,
Go ahead, Nikos.
Yes, I would like to summarize my own approach to this topic, that intelligence, whether it is artificial or natural intelligence, is meant to solve problems, to see through the complexity of a situation, to be able to solve problems. And that means to grasp the complexity in order to create a model. And the model has to be explanatory. That's what we do. Intelligent beings or intelligent software explains phenomena, and also, in the best cases, has a predictive value. So a good model is predictive. So this is the test of a good intelligence, whether it is natural or artificial. I just wanted to throw that in. Please go.
That's a great point. And here's an example. So these intelligent networks have a structure to them. They are interconnected networks, right? And so are the networks in the real world that we're trying to model. So if you're thinking about, how you create a path in a city and what is the best interconnected pattern, or what is the best structure of that, it might be an interconnected pattern. It might be that kind of deep network that we're describing. And in fact, that is exactly what Christopher Alexander's pattern language methodology seeks to capture is, if you will, sort of holistic fragments of larger networks, not isolated shallow nets, but pieces of the deeper network of a city or of a design problem or whatever it may be that you can work with as a deeper, larger network, as a more intelligent network. So, here's the example of a pattern, path shape in a city that has this deep network structure. So that's one reason that the pattern language has become an incredibly influential methodology in the software world, interestingly enough. In fact, it's one of the major methodologies of software design today, and it has led directly to many other spin-offs, and it's being used for many games, game design, for Wiki and Wikipedia. Wiki was created by Ward Cunningham to share pattern languages of programming. It has that same deep net structure, and of course, Wikipedia has a deep net structure as well. And that's a really exciting methodology that we can recognize and exploit when we're solving problems. Also, many operating systems use the pattern language methodology. Pattern language is a program or design patterns. Also, Agile methodology, which grew directly out of that work, extreme programming, Scrum methodology, and so on and so on. So this is becoming an incredibly influential and productive methodology in not only the design world, but management and many, many other fields. So when we think about that and we try to understand why that is being so helpful, we should remember that there is a strong corollary with how AI works. Remember this deep net structure that I was talking about, that there are actually these deep networks of knowledge, deep networks of the natural world and the real world, the physical world that we can tap into. And that is exactly what AI does when AI generates images. Now, here's
wait, Michael.
ahead,
I
Michael.
want to interject something, because many people in the audience of these series of podcasts are going to be architects.
Yeah.
And they're going to say, we don't care about all this stuff. This is technological stuff. Well, no, we really have to care about it, because here is where the drastic difference between what Michael says is the deep network structure and the superficial network structure.
Yeah.
The technology needs to understand the complex systems in order to handle it and in order to use it to create, say, the iPhone, and to create the software. It is overwhelming complexity, and it can be understood through the analysis. And they have found the pattern language tool extremely useful. Now, the fact that most architects do not use pattern languages reflects very badly upon architecture, because it is kept at a very superficial level. There is no cultural drive in the architecture of the last several decades to go into the deep structure. There is no deep structure, it's very superficial. So this is a huge difference that Michael is talking about, that is highly relevant to architecture, and at the same time, architects don't realize the existence of this huge structure, and I hope we can clarify some of these points in today's talk.
That's a crucial point, Nikos, because our focus in architecture upon novelty, upon creativity, upon, everything has to be new, it has to be different, it has to be somehow, exciting and novel. That is a massive handicap, structurally speaking, because what it means is that everything has to be a shallow net, not a deep net, right? We don't want to have that deep evolutionary structure, because that might look old-fashioned, or it might evoke some other thing, or we might be criticized by our professors for doing something that is, derivative, or, looks a little too much like something else in the world. Well, if you look at the natural world, all kinds of things look a little like something else, but they also introduce novelty. It's not that novelty isn't important, it's just that novelty needs to be balanced with this deep net structure if we're going to be actually truly intelligent. So as Nikos says, the pattern language has become much more influential in other domains, including software, but many others, than in architecture. And I think that does reflect badly on us in the architecture field. But it also suggested to Chris Alexander that maybe there were things that he needed to develop further with the pattern language. He recognized that there wasn't enough ability to customize them within the architecture world. It wasn't easy to interface with modern building systems, which are very conservative and slow and restrictive in many ways. And the crucial thing for him was there wasn't enough information about form and about geometry. And this is what set him on the next great phase of his work, his life's work for 25 years, over 25 years, which was a massive book called The Nature of Order. And I'm just going to briefly tell you a little bit about it in the context of our AI discussion, because once again, there is a connection here. So the issue of the nature of order is, well, okay, I'm going to deal, Chris Alexander says, with these shortcomings. How do we operationalize those? How does nature achieve the order that we see everywhere around us? We're in an era of the biological revolution, the genetic revolution, the understanding of complexity, complex adaptive systems, evolutionary systems. And Alexander said, so natural systems don't make little blueprints like we humans do. They make something more like codes or recipes that transform and grow over time, evolve, become more complex, more this deep net structure. And they are adaptive and they are emergent. You get emergent structures. And he concluded that we can learn from these processes. We can incorporate them. We've done so in our human past, and we still do so now to some degree, but those efforts are stifled in many ways. They're constricted by these sort of shallow net structures that are dominating our world and causing many dysfunctions, many problems for us. So let me give you an example of what he's talking about with these transformations. Here's a kind of simple example from the MIT physicist Harold Edgerton. He took a milk drop and he used a stroboscopic photography to show what happens to it when it hits a thin plane of milk. And the symmetry of that ball shatters. This is called symmetry breaking, and it's a common phenomenon throughout nature. And instead of turning into a kind of disordered mess, look at what happens. It actually creates new symmetries, new structures, and lo and behold, they have new emergent properties that are very complex. New centers, a new series of geometric properties, levels of scale, strong centers, boundaries, alternating repetition, positive space, good shape, etc. And Alexander observed this, and he observed that not only does this happen spontaneously in natural systems, biological, even physical systems like this one, but also in human cultures over the centuries. These same properties would continue to arise in human creations because humans are going through similar kinds of transformations. They're taking something and sort of breaking the symmetry and articulating new forms, new emergent forms that are evolving and transforming, and using patterns to create certain shapes, geometric shapes, that are coherent and that are beautiful and that are deeply evocative to us of our own natural place in the world, our place in the cosmos, if you will, right? So there's something
Yes, Michael.
profound
Yeah.
about this. Go ahead, Nikos.
Yeah, Christopher did the world tremendous service by extracting and documenting these geometrical properties, 15 fundamental properties over many years. And as you said, from all sorts of inspirations, the most wonderful man-made creations, all natural creations, and he distilled them. And that's not so easy. I mean, now that we have the 15 fundamental properties, we can recognize them. But in a beautiful thing, for example, the pictures that you're showing, either in nature or in a wonderful piece of human architecture, they're all mixed up.
Yeah.
So it is quite an achievement to separate them and document them. Once you know them, then you can recognize them. But when you see them all together, you say, oh, this is wonderful, but it's an ordinary human being who doesn't know the 15 properties cannot separate the 15 properties that they are simultaneously acting together and contributing to this wonderful sense of life. So this is a fantastic achievement that Christopher did, and he did that, and he documented in the Nature of Order.
Right. So I would encourage those of you who are interested in this, I hope many of you are, to read The Nature of Order, because what he does is he actually systematizes these properties. He's able to show that there are, roughly speaking, 15 of these that he was able to identify and create a methodology to work with them in our own work. And again, this is very similar to the idea that you're creating systems that are evolving and transforming as networks, as deep networks, right? And these are network structures. They're not just uniform networks. This image is a little bit misleading because all of the nodes are connected to all of the other nodes. And in reality, there are places that are connected and there are places that are not connected. And these are what form the geometric properties, right? So if you have a strong center, that's a deep set of connections. And then if you have a void around it, that's disconnected. So we need to remember that there's a pattern of connectivity, not just an interconnection. But that interconnection is also very, very important. And we now see this is going on all over the natural world, the biological and physical world. The way the genome works is a deep network structure. The way ecologies work is a deep network structure. The way the proteome forms structures and evolves, biological structures that we all recognize, the incredible diversity of the natural world and the incredible beauty of the natural world arises directly out of these kinds of processes. So this is something we really need to understand and identify in our own work and enhance in our own work, as we've done in the human past, but we've sort of lost connection to these deeper transformations. There are precedents. Go ahead, Nico. Go ahead.
You mentioned the forbidden word beauty. Christopher, all his life, and we too, Michael, myself, and our friends and colleagues, have pursued beauty as something really necessary for human life. And that's why we are teaming up with Sebastian, because Sebastian also recognizes the deep need for beauty for wonderful human life. So I wanted to mention that the revolutionary and hated word beauty is here. It's at the center of the discussion. Go ahead, Michael.
Very, very important point. And by the way, we tend to relativize the idea of beauty. Well, it's in the eye of the beholder and so on and so forth. But I hope you're beginning to see from this talk that actually it's a structural attribute. It's the Greek word omorphia, right? It's good form. It's the form that is well adapted to the problems of its complex environment, that we see that and we perceive that how important that is. We know that tiger's eyes are doing something important to keep it alive and keep it in the world in a amazing, vastly interconnected way. That tiger is aware and thinking and
excuse me. This is a jaguar, Michael.
Jaguar, thank you. Thank you. And all of these structures are doing that. They're functional, as well as we see them and we find it very beautiful because we're responding to those symmetries. We are seeing a symmetry with our own life and our own sense of connectedness to the world and our embeddedness in the world, our joy in being in the world. That's what the experience of beauty is all about, right? But it's a real structural phenomenon. It's not just some socially constructed thing. There's a socially constructed aspect to it, of course there is, but that's an addition to the biological and structural reality. This is a structuralist view of the world. And we can see that in human history as well, right? We can see fractal patterns in a lot of traditional art and design and other things that we now understand much better. And in the natural world too, as I was saying, the symmetrical patterns of leaves and fishes and even naturally occurring structures in the world.
So, Michael, isn't it time for us to move to generating wonderful compositions using AI and the 15 properties?
Yeah, so let's move into that. So first of all, I want to summarize the 15 properties that we don't need to spend a lot of time on each one, but you can read in the nature of order. Here they are, and they go from the sort of most immediate direct ones like levels of scale out to the most, you might say, cosmic ones like not separateness, just the idea that everything in the universe is connected to everything else. And that's not a truism, that's reality. It really matters that everything is connected to everything else and that we have that quality. And we understand these as transformations going on continuously. And, this is not a static set of properties. This is a dynamic set of geometric phenomena going on in the world around us that is the result of these symmetry breaking processes. So with that thought in mind, let's try a couple of experiments. Actually, I'm going to show you some experiments we ran before we started the video. We have
something before we start.
Yeah.
So first, I just want to, because it was maybe not clear for all the listeners. So the 15 properties you described, I think I'll elaborate it in the first volume of the 4 volumes of Nature of Order, right? Just for our listeners. So I will link the book in the description again. So you can, the Nature of Order consists of 4 volumes, right? And the 15 properties are part of the first volume. Is that correct?
That's right.
Described there. So I just want to, if all our viewers are listening, I want to go deeper into it. It's in the first volume of this series, and the pattern language you mentioned there already. I think most of our viewers knew that already. It's a fundamental book for I think any architect should own that. I mentioned that in the last podcast already. And I would like to add some thoughts about AI, which are like my own before we start, and would like to hear your opinion on that.
Yeah.
Because you explained again that AI, how is now like composed, let's say, or designed, like chat-gpt and Midjourney, tries to copy human cognitive ability, right? But actually, I thought about it and thought it's completely not. It's not like that. And if you look in the and that doesn't mean that AI is worse, but in my opinion, AI is even better than human. And that's also the reason, in my opinion, why AI can and probably will outcompete humans. So I will explain my thoughts. Because if we look actually in the construction of the brain, it's not that our ratio, so the logical part, makes the decision. As far as I understand the human process of the human brain, it's the limbic system, which is basically the center for the emotion, that makes a decision, like what to do. And as far as I know, the neocortex, so this is where the logical operations happen. The neocortex is only capable of giving advices. So the logical thoughts that AI copies happen within as far as I know, within the neocortex. And I think there are like surveys, medical surveys, when you, let's say, cut off, like hypothetically, the neocortex from the rest, it will run forever in alternatives, it will run forever in options, but it cannot make a decision what to do. So the limbic system is actually the center of the emotion that makes finally the decision, and it's just like, let's say, has just recommendations from the neocortex. So first of all, is that true as far as I understand? Do you know about that? Or, and then I can work out on that.
So I think we should remember that AI is a simulation at present of what human beings do. And it's built as a tool to help humans to do what we do, right? It's, it isn't at this stage what they, the sort of general intelligence that human beings have, which is a full-bodied intelligence, an embodied intelligence, embodied mind, that, clearly that's not the case. And there's a very famous book, by the way, by Hubert L. Dreyfus, called What Computers Can't Do. And there's still a lot of debate about that, whether AI is going to fully be able to do what humans do as biological entities. But I think what we should focus on for the moment is that AI is a very powerful accessory to human beings. And my own view is that that is how it should remain, that we should not allow AI to somehow supersede and hijack humanity, because that is a very grave danger. So if you want to use AI, for example, as a research tool, and you want to say, I can't afford Chris Alexander's full books, but maybe I can go to chat-gpt.
Wait, Michael.
Yeah.
I have two answers for Sebastian. The first one, if he wants answers on neuroscience, then number 3 webinar in this series, it has to be with our friend and colleague Alexandros Lavdas, who is a PhD MD neuroscientist. Okay, the second comment is that AI really can take either of two forms. One is a survey of billions and billions of pieces of data. So it's not really intelligence, it is gathering data and putting them together. The other way is to actually generate things intelligently, and that's what Michael's going to present. Actual generation, not gathering data, generation of new designs and patterns. So please go ahead, Michael.
So I think there's two major ways that we can use AI very effectively today. One of them is as a research tool, and you don't treat it as a final word on the subject. That is very dangerous because it can hallucinate. It can be wrong. It can be about like a high school student or a freshman college student perhaps writing a paper. It's not necessarily getting everything right, but it's a first step. If you want to say, well, what are these 15 properties? And you ask ChatGPT, it will give you a pretty good overview that'll give you at least a general summary of the subject. But then if you want it to do something more sophisticated, like can you draw examples of the 15 properties? Look at how it actually is quite bad at that. And even the words are mangled there, and the drawings they make no sense. If you compare the actual drawings that different people have made or the photos that Christopher Alexander made on the lower right, the AI is not there, right? So you have to be careful where it is effective and where it's not effective. And it's not going to necessarily give you gospel. But there's some other sophisticated things that you might not know about, kind of like Wikipedia, because again, AI, ChatGPT and others draw on Wikipedia and other internet sources that can be quite helpful in these research tasks. So if you want to know, there's this thing called harmony-seeking computations that Alexander was working on. What's that all about? So you give it a prompt and ask about that, and it begins to tell you about that. Well, patterns, he kept working on patterns, recursive processes, etc. So it's a good tool, I think, for basic research. Then once again, if you start generating images, it's not quite there. Here's where it generated an example of harmony-seeking computations and what those characteristics might be. But then, you know, we were talking earlier about beauty, and do people have shared aesthetic preferences, or is it all just, you know, in the eye of the beholder? Lo and behold, there's a lot of research on that subject, as Google AI will tell you that, and it'll give you citations, which is very helpful to be able to check and verify some of these things. And if you're you know, writing a paper or something, you're going to need those citations to be able to really provide the evidence for what you're showing in your paper. What are those aesthetic properties? It'll give you a pretty good summary of those, at least what the research is showing. You know, what are the studies and theories? Prospect refuge theory, biophilia, et cetera, attention restoration theory. And look, what do you know? Pattern language by Christopher Alexander is showing some of that work as well. So then you say, okay, draw a beautiful building as judged by most people and their natural aesthetic preferences. And this is what I got. Now, this is a bit kitschy, you might say, a bit, you know, clumsy, a bit like a McMansion maybe, but it does have some interesting characteristics that we might want to make note of. For example, the presence of water, the presence of greenery, the presence of symmetry, and it calls out some of those: large windows, natural materials, etc. So, you know, it's, again, it's interesting, and I wouldn't take this as an actual design that I would use for any client, certainly, but it might be interesting just to investigate something like this. Here's another one. This one becomes more classical, but again, a bit overwrought, a bit sort of McMansion-esque, you might say. Here's one that I said, the characteristic that Christopher Alexander describes, and this is what you get. Nikos, did you want to comment?
Yeah. We just made a significant switch. The first two examples were a survey where the AI draws upon 1 billion pieces of information, and therefore puts together kitschy stuff that many people like. So this is not generating something interesting, it is putting together data. Your next question specifically asks to go to the nature of order. So it uses results of Christopher in order to generate something. And so this is more sophisticated because it is generating something using insights of Christopher that is in the nature of order.
And you can do that, and I would encourage anybody using AI to do that, to be specific about where the geometric sources are coming from, and also be iterative, right? Ask it repeated questions or get it to refine, get it to keep going. And so I kept going. I said, okay, what about a traditional courtyard that contains the geometric attributes? That's a little bit more interesting, I think. Then went back to the Alexander thing, and it began to draw another building that looked similar to the earlier building I showed, a bit, I would say Mughal architecture, perhaps, something like that. Or then if you say a traditional and vernacular style, similar to what has been proposed and built by the architect Christopher Alexander. I'm not sure why it did this, but it went to a more sort of rudimentary drawing style, less naturalistic, more like a SketchUp model, actually, which is interesting. I'm not sure why it did that. This is part of the other problem of AI, is that it's a black box. You can't really peer into it and see what it's doing. You can ask it follow-up questions, but it might not even know itself what it's doing because it is a very, very deep network.
Sorry to interrupt that in this case it looked at some student works that it could find on the internet, because they're like it's just like combining things that it got fed with, right? Of course. Yeah. So it's like and before I think it combined different things, probably from architect visualizations, and this looks more to me, it looked at something that students did. Yeah. And this looks like an ArchiCAD model to me, or something like that.
Right, or SketchUp, right. Right.
Yeah, maybe SketchUp, yeah, student work, I guess.
Right. And then did a couple of experiments where I said, okay, what about certain architects? Can you do something kind of like those architects? And I used the Egyptian architect Hassan Fathi. Actually, this is far more ornate than what Fathi would typically do. I'm not sure why it drew it this way, but nonetheless, that's interesting that it would, and then the geometric characters that most people would consider beautiful. Now, there are a lot of the 15 properties here, levels of scale, strong centers, boundaries, alternating repetition, etc. So it's interesting, again, as a study model, perhaps. Then looking at some of the other sort of what you might call stylistic, although I don't personally like the word style because it's a post hoc classification. I prefer the word character, or even better, the word form language. But if you say plan and elevation, it'll generate a plan and elevation for you that is credible on first blush, but if you look closely, you realize that the plans are pure hallucinations. They don't work, and there's some very strange characteristics about them. Again, though, it's interesting as a study model. Alsatian half-timbered, this is a rather overwrought one, so I told it to make it simpler. This is a little bit better. Brittany, so I'm using some historical characteristics of different architectural geometries from different regions, because those would have evolved and adapted and transformed into something unique, right? So what about the traditional Brittany half-timbered architecture? And this is what I got. Or if you say, again, going back to specific architects, the architect C.F.A. Voicy, can you draw that as a series of asymmetrical gables? And this is what it drew. And it's interesting how it went on and it sort of elaborated. Oh, well, it's a mix of whitewashed plaster and natural stone, tall, narrow windows, wooden shutters, large arched wooden door, intricate detailing. Now, you could show this to a client and say, what is it about this plan that or this building that you like? Do you like the tall, narrow windows? Do you like the whitewashed plaster and natural stone? Do you like the, you could use a series of these with a client to explore some of the form language that you might want to use in a building that you're doing for a client, perhaps, as opposed to actually trying to do a design through this kind of tool. Here's another one where I said, okay, well, how about Spanish courtyard architecture? And I'm not sure why, but this is a little bit distorted. Again, probably taken from someone's drawing where they didn't quite have the three-dimensional geometries right. If you look at the fountain, it's a little bit off, etc. But anyway, interesting. Lush plants, colorful flowers, arched colonnades, red tile roof, etc. Beautiful Egyptian courtyard building, and this is what I drew. Again, the plan is a pure fantasy. It's like a mishmash of things, a little bit like somebody's dream or hallucination, perhaps. But as these systems evolve and transform, I think, and this is already happening in some proprietary systems, they are able to clean these things up. And again, this is a technology that is able to learn and grow and transform and become more accurate over time. Nubian architecture, I was trying to get a little closer to what Hassan Fathi actually did, and this is maybe a little bit closer to that, not quite as nice, certainly. Here's another one that I think is quite interesting. I asked it to do a mixed-use urban environment that involved generous pedestrian spaces, transit, multimodal transportation, buildings with a lot of mixed use in them and diverse uses. And this was, I think I talked about desert architecture, and it ended up doing something it looks a little like something in the Middle East, perhaps. But, again, it could be an interesting study drawing or an interesting example of what AI could generate as a way of stimulating thought.
Let me cut in here. All of this city was drawn by AI.
Yeah.
This is not the greatest example, but look at, in one step, this has undone 1 century of homogenization,
Yeah.
of repeating blocks of the same size. Look at the variety here.
Yeah.
Okay, AI has just slapped us in the face. Human cities have variety, slightly different size buildings, slightly different width alleys.
Yeah.
It is a city you would want to live in. It is a city, if you show this picture to a client, they will say, oh yeah, let's build it. You know, it really looks attractive. I'm going to make a ton of money after building this. So this undoes the homogenization, the military repetition of environments that we have been building for close to a century. I
Right.
think this is the important point, that
Yeah.
we are breaking all taboos that have led to cities that are not very nice to be in.
And we can explore these options with AI, with its generative capacity, as Nikos was pointing out. It's able to create that variety and that dynamism of real cities, or at least some aspect of it. Again, this is a model that it's generating. I wouldn't build this. In fact, you can't build this. If you look closely, there's some impossible sort of Escher-esque geometries going on here. But nonetheless, this is a very helpful exploratory tool, I think, to look at alternatives to, the sort of slabberbs of the same building over and over and over again that we're seeing in many parts of the world today, et cetera. And the computer technology is going to be able to allow us to actually translate that into real buildings with proprietary systems where we could say, I want you to finalize this plan and make real building plans for each one of these buildings and give me costs. Give me all the data that will show how much this is going to cost and, all the things that you're going to need to know that would normally take you months of work to develop, or other software systems that are much more rigid and not generative in their technology, not using AI. So I do think this is a frontier that's quite exciting in many ways in terms of how it can actually create systems of delivery that are much more naturalistic and much more complex and emergent and generative in the way they do things. Now, there's 2 different paths we can take here. One is to use that generativity to create fantastic novelty, right? Neoplastic forms, all kinds of exciting, new, wild, weird, swoopy shapes and so on and so forth, expressive pieces of art. Well, people don't live in art. People live in cities. They live in places where they have needs. They have the need for spatial enclosure and complexity and control and affordance and all of these things that we now know from the research. And I would say to my colleagues in the profession, I think we have a moral responsibility, an ethical responsibility as professionals to put the user first and the user's needs first, and not to just create superficial novelty, these shallow nets, whether it makes us feel good as artists or as creators, that's beside the point. And that's very selfish of us to say, oh, well, I'm a great artist. I'm going to just impose upon human beings what is my version of art. By the way, doing it often in a very sort of corrupt relationship with the economic realities, instead of being in service to human beings and putting those human beings, those users first. I do think there is a real professional responsibility here that is profound, and that it is really at the core of where we are as the profession today, and the crisis in many ways in the profession of abdication of our ethical leadership we've seen.
Michael has gone way off and left AI discussion. But this
I
is
do think this is the issue. I think
it is the big obstacle to introducing human scale design in which AI can play a fundamental role. Namely, the adoption of an ethical approach to design where the user's health and well-being is primary, and not the imposition of swoopy artistic abstract shapes, which is unfortunately what the high-level architectural world has been applying all this time. And as Michael pointed out, this is the danger. that the architecture will adopt AI not to build modest, wonderful living environments like the one we see here, but to create even more unlivable, inhuman environments where you have giant swoopy shapes that look very nice on the front of an architectural magazine. So AI can be misused terribly by the architectural establishment in power in order to perpetuate this very shallow approach to architecture that does not care for the user. This is unethical. Michael has pointed this out, and which way AI will continue to be applied in the future depends upon an basic ethical decision that the profession has to make.
And
May
there's
I also add something there?
Go ahead.
What I hear is that I think I would go even further. So it's not, I wouldn't only blame the current architects because they also come from somewhere, right? This is actually what they got taught already in university. So I want to point out that the root is actually even earlier, is when the first semester student first times goes to the design class. He will be raised to have a great idea. Now they call everything concept. I've seen several design courses in several universities, well, in different parts of the world, and they overuse the word concept to justify every nonsense. But the students are already taught, as I said, not to be not to provide a service to the society by their design, but to become, let's say, an artist, a creative artist, and they will get compliments from the professors when they have a great creative idea. So I don't want to blame the current, currently working architects, because they got trained like that already, probably in university, right? So and I also mention this because I know to this episode of our talk or the podcast, some architecture students will listen too. So I would just want to address them and say it's really up to you to to look through this tale that you got told every day by your professors, and actually all professors, not just design professors, also historian and so on, and that tell you that what Michael just laid out, so that you should be a designer and something. And I mean, Michael said that we should not be like that. But I mean, I just want to address the student that listened to that. So please look through the stories that you got told every day by your professors. And it's not true like that. It's more like that we have to do a service to society as architects based on ethics. And you call it morality and ethics. And I think it's totally correct. So it's the root in the universities and also in the magazines and in the architecture press. I mean, they convey this myth of like the creative architect with a great idea. I mean, that's not what it's about.
Yeah, I don't think it's
Sebastian. Yeah, Sebastian, you have defined the topic for another webinar on the bankruptcy of architectural education in our times, where a prejudice is ingrained from day one to say, this is beautiful, this is not beautiful, do this, do not do this. Well, the examples that Michael generated using chat-gpt, you may think they're a bit kitschy, you may don't like them, but they're all livable. Okay, you could live in those buildings. And those represent the opinion and the liking of billions of people. That's why AI got them, by collecting billions of pictures from the internet. And then the student is told, you make this horrible crumpled building, and don't do anything like the pictures that Michael showed you, because that's not currently in fashion. Well, is this young student being trained to be an architect for people or not? Or to create giant abstract sculptures? That's extremely arrogant. And unfortunately, that's what the schools are producing, extreme arrogance, and with the message that these comfortable looking buildings are not in fashion, and we are superior, and forget the user and forget what the majority of the world's population likes. This is a terrible problem, and of course we cannot address it here. But thank you, Sebastian, for raising that. It's a huge problem, and maybe we can devote a future webinar to this.
But I think it's connected to what we're talking about here, because the question, I think, for all of us, students and professors and practitioners and others, is what kind of world are we moving into, and how should we respond to it? I would argue that the fantastical swoopy shapes and all of the sort of, art-led approach. There's a very important place for art, don't get me wrong, but the art of novelty, the art of everything being radically creative and new, that is sort of the ideological core of a lot of architecture today, is actually a form of corruption. It's something that the industrial system has found very advantageous, and it's advantageous for a narrow slice of the population, the wealthy. It's fine if you're wealthy, you can live in these swoopy buildings. There's every luxury afforded to you, but everybody else has to sort of suffer down on the lower level. And furthermore, it is not a sustainable regime. We are hurtling towards catastrophe, and we have to recognize what kinds of transitions we're going to have to make. And far from being old-fashioned and backwards, I think moving into this, if you will, timeless understanding of nature and culture and history and human experience is the future. It is the new science, the new understanding of complexity, complex adaptive systems, evolution, transformation. And this is what AI is rooted in. This is why AI is telling us these things about our world and about what preferences are. It's surveying the research and telling us, no, there are human constraints here, and there are natural constraints that we need to design around and adapt to. We can't just continue this sort of fantastical, utopian artistic world that is hurtling us off the cliff. We do need to confront our responsibilities. So it's not about blame necessarily. It's about what is this moment in history, and where are we moving towards? Where do we need to move towards? And what responsibilities do we all have in making choices?
Michael, I want to throw the blame, because what you have so clearly delineated is not mentioned in architectural culture. It is not mentioned in the architecture schools. If it were mentioned, then we say, okay, so people are aware of the problem, they're going to do something. But it's total silence. That's why I hope people will watch this video to be aware of the problem.
Well, I think there is a corruption at the heart of this, actually. And I use the word corruption very specifically in the sense that we've lost our ability to put the deep nets together. We're trapped in a shallow net that's serving only a narrow interest, or a narrow set of interests. That's the corruption that I speak of. And that is not sustainable. That is not going to lead us into a place where humanity is going to be well. And therefore, we all need to ask questions about where we should go as an alternative. And, architecture as a profession likes to reinvent itself and likes to tell the story of how it is dynamic and changing. And yet, I think this is a form of ossification that we're in currently. It's a sort of trapped in a 1930s model of industrial environmental creation. And if we're going to move beyond it, we really have to examine its core tenets, and including the one I mentioned, which is the idea of radical novelty, that everything we create has to look different. It can't look like anything from, quote unquote, the past, which is nonsense, by the way, from a biological point of view. It'd be like if you told evolutionary structures that they have to stop looking like anything from the past, and we have to start all over and start with bacteria or single-celled organisms.
Yes, you cannot include the liver or a heart, because those have been used before. So you have to find a new system.
Walter Gropius said we have to start from zero, and that was actually a very, very damaging idea that is still entrenched today.
And it's also not even possible, I just want to add. So even when you do like creative forms, let's say like Gehry or Zaha Hadid, it's also like forms that exist before. They just like take forms, they call it then organic, but it's totally not how nature looks like. But they call it, let's say, Zaha Hadid organic, and then scale it up to a building. That's that's not even completely new form. It's just a form that's there before, used in a different way. And in my opinion, something that's not working well, because these forms often, let's say, Zaha Hadid buildings don't work well as a building. But
I was just going to say there's a lot of self-contradiction and I believe self-delusion involved in a lot of the theories of architecture today, which do not stand up well in the light of critical examination by other professions like philosophy and others.
Yeah, shall we move to AI?
While we are discussing these things and linking them to science and AI, there is a chorus of praise on the outside. The press says, wow, fantastic buildings. These are fantastic buildings. They don't work, but there's a chorus of praise. And the people hear this constant praise and they're brainwashed.
These are the shallow nets, I think, that are also clogging up the culture at a broader level. Nikos, I want to get to this output that you gave me a prompt and I put it into chat-gpt, and this is it up here. List the geometrical characteristics of visual patterns that embody very low human intelligence. Now, that's not meaning to insult anybody. That's simply meaning to say, if you're failing to solve a problem, if you're trapped in a certain, ideological dead end, expressed in terms of a lack of relationships, if you're isolated, if you're failing to make connections that you need to make, or if there's, you have a brain injury or whatever it may be. Argue why logical relationships or intelligence are analogous to geometrical relationships. Use Christopher Alexander's 15 fundamental properties plus other types of symmetry to express the results. Then everything below that is what chat-gpt gave as an output. And we don't need to go through everything that it says, but it's quite amazing, actually. If you look at it, they often reflect a lack of logical relationships and coherence. This can be expressed in terms of randomness. It used that word independently. Lack of symmetry, absence of meaningful structure. And then it articulates it in terms of Christopher Alexander's 15 fundamental properties and additional types of symmetries. And then it goes through the 15 properties, levels of scale, low intelligence, high, and then it compares each, low intelligence and high intelligence. Visual patterns lack varying scale. High intelligence visual patterns exhibit a hierarchy of scales. And it does that for every one of the 15 properties. This is really amazing stuff, actually, that it's able to generate these analyses of how in the case of each of the 15 properties, there's a comparison. I'm just going to scroll through them, and if anybody wants to, maybe you can go back through the video if you want to read these. And I want to add one thing about this conclusion. This is chat-gpt speaking again, its own conclusion. And when it says order, symmetry, and meaningful relationships, the order and symmetry are not in the simplistic, like rigid, everything lined up, and symmetry, everything left and right, and blah, blah, blah. No, these are deep forms of order and symmetry. In other words, order, the order of nature, or the nature of order, right? The Alexander book, which is a complexity, complex systems, biological order. And symmetry is also many different forms and many combinations. There's not only left and right, there's rotational, there's translational, there's scaling symmetries, tiling symmetries. There are combinations of those, like in a kaleidoscope, or in a natural environment where you have fractal patterns and bilateral symmetry and many other forms of symmetry. And then deep symmetry, our relationship between ourselves and what we're seeing, the symmetry between ourselves and the world. All of these things that are very, very important, I think. I think there's a new understanding coming out of mathematics and physics of symmetry and symmetry breaking and how important it is, and how it's really revolutionizing our understanding of biological structures and human structures, artistic structures.
Let me interject some public relations. Michael and I have written either individually or jointly research papers on symmetry, complex symmetries. There are about 5 or 6 papers, open access, so people can read them for further details.
Yeah, I saw them on ResearchGate. I think I will link them anyway. I will link both of your ResearchGate profiles under this podcast. So viewers are very invited to read through their publications. I thought we want to do live experiments too, or not? Or is this, did you just want to show the ones you have done previously?
Well, we can do a couple of real-time ones if you'd like. Sebastian, would you like to make a prompt?
I think we should, I mean, usually ChatGPT remembers what we talked before, right? So if you open a window and tell them the 15 properties, I thought that's what we kind of gonna do, or so kind of copy paste the 15 properties, or maybe ChatGPT remembers them. I think you could ask also in general,
It will know them. Yeah. Can you draw a building that encompasses? I think this is the least sophisticated part of chat-gpt at this point. You know, there are others that maybe are a little bit more powerful. This is interesting. It did the elevations, but again, these are not realistic elevations. They're somewhat hallucinatory, I think. But interesting that this is.
Yeah, but look, we have uncovered something profound. We can play with this, okay? And you get interesting results, whether they have the 15 properties or it's modern. But there's something there. There's the deep net, the 15 properties, the symmetries.
Yeah.
Today's architecture students don't have anything. They just widely make doodles.
Right.
They're not grounded in anything.
Right.
All the stuff that we're talking about and we generate is grounded in something, and we can go back and change it and fix it and approximate it. This is really a revolution in the way of thinking about design, because it is grounded in something that has been tested and comes from properties out of nature, out of biology.
Yeah.
And I just want to also point out, this is just the first generation we use right now. DALL-E, I think this is DALL-E doing that, right? And Midjourney is just like existing 1 or 2 years for the broad public. So how will this be in 4 or 5 years? So I think that for now, the main point is still the main problem, that AI does something, but it doesn't know why it's doing it and does not really understand it deeper. So for example, the first images that Michael showed at the beginning of the conversation, there were like, even symmetries were wrong. The columns were like, something, if you look more detailed, it didn't really work because it doesn't know that it does a column. It just does something that it knows from other images, and it happened to come out something like a column, but it doesn't know that it's now doing a column. So, and that, for example, or anything like that. And so if AI at some point, I think it will come in the future and probably sooner than we think, let's say in 4 or 5 years, maybe, how will this evolve? So if AI really understand the 15 properties, that's what I mean, not just like read through it and do it, but really like understand it deeply, if we like we humans can do, then I think the outcome will be much more impressive. Technically, in the next step, you could like, I mean, ChatGPT is like one large language model, right? So technically, someone who is an architect and good in IT could code, and it doesn't need to be even a large language model. It would be something like a smaller language model, right? Like, how you say, putting so for example, the 253 patterns from a pattern language, right? Inserting that into it, this would be like a small language model already, right? And then creating an AI out of that that generates pictures using these, for example, patterns, right? Yeah. So this would be something out of, I mean, separate from DALL-E and Midjourney, right? So that would be possible.
We have a colleague who's, this is very strange. We have a colleague who's actually working on that, has been doing some work on that, of actually applying patterns to generate, and also to look at photographs and read the patterns that are in those photographs. Very interesting stuff. Anyway,
I want to say something.
Things are going to be happening, I think, as time goes on.
Yeah, that is not very good.
Positive.
I want to say something that Sebastian brought up. The 15 properties work very nicely on the architectural and urban scale in abstraction. However, the actual patterns are the ones that shape the public space, the urban space. And that's where most design mistakes have been made during the 20th century, unusable public spaces. So you need the 15 properties plus the patterns for the urban spaces. And so that's just a programming task.
Yeah.
And we'll get wonderful urban spaces.
I mean, for now, actually, it would be possible to, let's say, open, I mean, I don't have the pro version of it, so I cannot use this DALL-E, but to open a new chat in DALL-E and insert one by one all these, I don't know how, I don't think it can remember so much, but I don't know how many prompts, so insert all these 253 patterns plus the 15 properties.
You don't need all of them. All you need is about 15 for a particular project.
Yeah, but I mean, like feeding the Midjourney with, the AI with these knowledge, like we would remember it if we read the book, right? If an architect reads the book, they will kind of remember them in the kind of in his mind,
Incorporate them,
and recall them when he need them. So that's the point, right? You should not apply them all at the same time, but recall them when you need them, and then create something new. Like we talked last time, you're still creative, you still create something new, right? But knowing them. So AI is missing this knowledge, right? Technically, this wisdom, right, as a backbone.
Well, it can, yeah. I mean, it depends on how the system is developed and what kinds of prompts you use. I mean, you can have proprietary AI systems that are more focused and use these more limited language models or models of whatever kind that they're drawing on from the data. But another point about patterns is that you can write specific patterns for a project pattern language, which is something I do in my own work. And you can draw from the 253. We have another collection of 80 patterns in a new pattern language for growing regions. And there are other patterns that can be drawn on, and new patterns can be written for a given project. And those could potentially be applied to a proprietary AI system that could generate plans, or at least analyses that could then the human could do the plans. So again, I want to end on this note in particular, that we can use AI, misuse AI, or AI can misuse us to further increase the shallowness, the shallow nets of the world, the superficial titillation, pseudo-intellectual nonsense, fashionable nonsense, image-based noise, banality, and clutter. And that goes for some of the neoplastic stuff as well as the sort of kitschy stuff. They're all related in the sense that they're shallow nets. They're not deep structures that are integrated into their world and that touch us because they're profound. And so, again, I think we need to draw on these deep nets of human history and of nature,
Michael, may I
history,
interrupt
and
you?
curate the results carefully. Just to finish, Nikos, and then using AI as a research tool, but to enrich the human process, not the AI technological process. Yes, Nikos.
Yes, there is a big difference. The inhuman, artistic, abstract stuff is dead. It cannot help. The kitschy stuff can be fixed, can be formed to make it more human, because it's going in the right direction. Whereas the other stuff is going in the opposite direction. I think it's an important distinction.
Yeah. I think what our viewers can take away from this, Nikos, you want to make another closing statement, or?
No, I think we have covered a lot of stuff, not completely. We have thrown out ideas, provocations. That's the point of this webinar, to get people thinking, to say, wow, I didn't know this. This is worth investigating. And as you, Sebastian, point out several times, this is on the crest of a wave. This is developing every week. The capabilities are increasing. So we are on the cusp of a huge progress, that we can have these fantastic tools to do what we dream about.
Yeah, I think for now what we can take away from what we've seen is then, of course, I think we all agree we cannot take the Midjourney or DALL-E pictures in the same way that it was created. But I think the interesting part of what it shows when you tell him to show something, that how you prompted, like what people like, what is that natural, like how people want to live in, and it will not show the Bauhaus box. So if you prompt DALL-E and probably also Midjourney, show me what the people really like, let's say, or how people want to live, or let's say environments that have proven as well functioning for a society to live in, it will show these pictures or images that we've seen at the beginning, right? So I think this is a learning we can all take away. And second, what I always want to stress is, I mean, of course, architects should be like, how to say, I mean, we all should be like critical thinkers, right? Architects or non-architects, but I know our listeners are partly students, as I said. And I think it's so crucial that you don't believe like everything people tell you. Also don't believe what Nikos and Michael tells you, right? If you Google their opinions. So don't just like eat what you got fed with, no matter what it is, but really like be critical and look through the opinions you got told. And I know my own experience, not so easy to do that. So to look it through and try to understand the patterns and the mechanisms behind those opinions that you got told. So mainly in university, right? By your professors, also in magazines and so on. So really look through the stories that you got told and then try to develop your own opinion. And I mean, maybe our listener come out to say, well, I want to be a completely modern architect and I want to do Bauhaus-like buildings. I mean, fine, I wouldn't kill you or judge you, right? It's like, but I really want like every listener think critically through and take also the input that you got today. And of course, I think input is always a good thing. So look into history, as I'm teaching on my channel, and see what you can adapt for current contemporary architecture, but also look in what we heard now, the pattern language for sure from Christopher Alexander, and these 15 properties and other content from the nature of order. I think it's just like good input you can take and then create something new for our current times, right, as an architect.
Don't believe the shallow nets of whatever it might be. Believe deep nets. Construct your own deep nets, your own deep learning, not just about what architecture has been for the last 100 years, but what architecture has been for the last 10,000 years and what nature has been for the last 4 billion years, right? And what we understand about our world and how it's transforming. We all have choices to make, whether we're going to continue on this path that seems to be heading right off a cliff, or whether we're going to somehow recognize the transformations, the transitions that we're going to have to make and what those involve. And I believe they are going to take us away from what we've been doing for the last century, because it is truly unsustainable, and moving in a direction of embracing these deeper patterns of history and nature.
A wonderful summary from Michael. I cannot add even one comma.
No, I can add one thing, and I just wanted to add that it's actually timeless to do so, right? Because the criticism is often like, yeah, you'd go back and you do something like 200 years ago. And I mean, some people want to build like a Baroque palace, like as it was exactly. I mean, I don't want to comment and judge that now, but I mean, if you look on these, we talked about that last time already, Nikos. For example, the pattern language patterns, or the 253, or the 15 properties. It's like elements and patterns that can be like a backbone of something that you create new, right? So it's really a timeless strategy, or what Michael just said now, to look at the, let's say, the principles of the universe. It sounds a bit like kitsch, but that's actually what it's about, right?
It's a biological model. It's not about going back, and it would be about, you know, I don't know, mammals becoming dinosaurs or something like that. It's about going forward, right? But going forward, not by simply jettisoning the past and going back to, you know, I mean, that would be truly going back to like bacteria or something and starting over, starting from zero, as Walter Gropius put it very faithfully. We need to go forward, building on the evolutionary treasury that we have, and building on the DNA, but exploring novel areas from that evolutionary base, not by wiping it all out.
Yeah, that's a very good final statement, I think. Yeah, exactly like that. Okay. Yeah, thank you very much for your time and presentation.
That was fun to explore. I don't think we got very much out of the live exploration, but oh well.
Yeah, but that's fine.
They can play with it themselves. That's the thing. And then they can, you know, whether they're using that one or Stable Diffusion or you know, any of the other technologies out there.
Well, thank you, Sebastian, for arranging this. This was fun, and I hope that the viewers will get something out of it.
Okay, thank you very much for your time.